All right, guys, so let's watch and listen carefully here. All right, so for our first question here, I've got beryllium reacting with oxygen to produce beryllium oxide. Okay, what kind of reaction is that? Synthesis reaction, right? So give them 1 mark for synthesis, give them 1 mark for writing it out in words. Beryllium, okay, plus oxygen, okay, will give us beryllium oxide. No capital letters, okay? And then we got to balance this thing. So looking at the highest number, that's oxygen, okay? There's 2 on this side, so I need to put a 2 over here, and when I do that, that gives me 2 berylliums, okay? 2, 1, 2 for that one. Okay, so 1 mark for the balancing, 1 mark if it's written out in words correctly, and 1 mark for the reaction type. No, if they left that blank where the 1 is, that's fine. Okay. Remember, we only have to make sure we write ones if it's a fill in the blank, but it's not a bad habit to be in. Okay, for our second one, I've got an ionic compound reacting with an element, forming a new ionic compound in a different element. What kind of reaction? Single replacement, so 1 mark for that. Okay, writing this out in words, we've got calcium carbonate. Okay, plus lithium. Okay, gives us lithium carbonate. And calcium, again, all lowercase. To balance this, okay, the thing present in the highest number right now is lithium. There's 2 of them over here, so I need a 2 over there. Then I'll check everything else. There's 1 carbonate here. There's 1 carbonate over here. There's 1 calcium. There's 1 calcium. So really everything else is a 1 except for the lithium on the reactant side. All right, 1 mark each for those. Okay, and then number 3. All 4 of the things in that reaction are ionic compounds, so it is a, what kind of reaction? Double replacement reaction. So 1 mark for double replacement. Okay, we're looking at iron 2 oxide. Okay, it's reacting with sodium bromide. Listening, please. And that's going to give us iron 2 bromide. And sodium oxide. Okay, and remember that I figure out this Roman numeral by looking at the non-metal. Oxygen always has a charge of -2. This means that iron has to have a charge of +2, so I use the Roman numeral 2 there. Okay, so 1 mark for the reaction, written exactly as I have it. Then we got to balance. Right now, sodium and bromine are both 2s, and I can balance the whole reaction by making sure there are 2 of them on that side. It's also 1, 2, 1, 1. Okay. Questions on 1 through 3? All right. For question number 4. Okay, writing out in formula form. Okay, guys, I need you paying attention up here. Okay, I've got copper 2 nitride, so that's copper with nitrogen. The Roman numeral tells me I've got to use the +2 charge when I drop and swap with nitrogen, which is a -3. So this will be Cu3N2. Okay, and it's going to break down into nitrogen gas and copper. Now, nitrogen gas is one of our special elements, so it gets a 2 beside it. All right, so if their reaction looks like that, you can give them a mark. What kind of reaction is that? Decomposition. 1 mark for that. And then we got to balance it, and here's again where if you don't get the swaps and drops right, it's really hard to get the balancing right. Okay, I got 3 copper over here. That's what I got to balance first, so a 3 there takes care of it. There's 2 nitrogens on both sides already. Okay, so everything else is basically a 1. Questions on that one? Okay, for number 5, okay, I've got heptane here, so that's C7H16. Okay, and it's going to burn in the presence of oxygen gas. That's O2. to form what all combustion reactions form, carbon dioxide and water. Okay, so obviously we get a mark then for saying this is a combustion reaction. Right, so if their reaction looks like mine, give them a mark. If they got combustion, give them a mark. They can do that, that's fine. It's going to be harder to balance that way. We only use HOH, guys, if we're dealing with a replacement reaction. For a combustion reaction, it's easier to leave it as H2O to track where everything goes. All right. Does this one require the rule of 2? No, 7's an odd number. All right. So 7 goes here, that balances my carbons. There's 16 hydrogens. Now there are 16 hydrogens on that side. Now I've got to look at my oxygens. 7 times 2 is 14, plus 8 more is 22. 11 times 2 is 22. Questions on number 5? Are these out of 2 now or 3? No, they're out of 3, because you get the reaction, the balancing, the reaction type. Okay, potassium permanganate. So potassium is K, permanganate is MnO4. It's one of your polyatomic ions. Reacts with magnesium hydroxide, Mg. Hydroxide is OH. Okay, I got to swap and drop both of these because they're both ionic compounds. Permanganate's a -1, potassium's a +1, so that one's okay the way it's written. Okay, magnesium's a 2+, OH is a 1-. So I need brackets around the OH. Okay, and it's going to form potassium hydroxide, KOH, -1 +1, so that's good, and magnesium permanganate. Okay, this is a -1, that's a +2, so I got to drop and swap and get a 2 over there. All right, if their reaction looks like that, you can give them a mark. What kind of reaction has all ionic compounds in it? Double replacement, give them a mark for that. Balancing, right now, I'll start with OH, because there's a 2 on the reactant side. So if I put a 2 over here, that balances my OHs, but gives me 2 potassiums. So I come back over here to make the potassium work, Thomas. Okay, and then I've got 2 permanganates. Well, there's 2 over here, so that's okay. 1 magnesium, 1 magnesium. All right, so now it's balanced. 2, 1, 2, 1. Okay. Questions on that one? And remember that balancing must be in the lowest terms. If they have 4, 2, 4, 2, it isn't right. Okay, it's got to be in the lowest terms. Questions on 6? Okay, last one, prediction question. I've got calcium chloride is going to react with iron 3 bromide. They are both ionic compounds. What kind of reaction is taking place? A double replacement reaction. All right, it's important for me to know that because now I know I've got to do what with my metals? Swap them. All right, so it doesn't matter which order they write the compounds in here. Okay, I'm going to say that that's going to mean iron ends up with chlorine and calcium ends up with bromine. Now, they could have had calcium and bromine first and iron and chlorine second. That doesn't matter. Okay, now I've got to do what with these 2 ionic compounds? Give them their numbers, drop and swap. Okay, on this side, iron was a 3+, so it needs to be a 3+ over here. That'll give me FeCl3. You want to pay attention? Okay, on this side, I've got calcium, which is a 2+. This is bromine -1, so I got CaBr2. All right, so give them a mark for this compound and 1 mark for that compound. Okay. Now we've got to balance the reaction. I've got 3 chlorines over here, but only 2 over here. What's the lowest common multiple? 6. All right, so if I multiply this side by 3 and this side by 2, that balances my chlorines. Gives me 2 irons, however, so I've got to go back over here and make sure I have 2 irons on the reactant side. That gives me 6 bromines. If I go over here, now I have 6 bromines and 3 calciums. There's 3 calciums over here. Okay, so make sure that you apply these correctly. There should be 3 calcium bromides and 2 iron chlorides in case they wrote it in the other order. Okay, so mark for the balancing and a mark for each of the compounds. And that is how I would give you marks on a test for a question like that. 1 mark for each of the products, okay, and a mark for balancing. You would not get a mark for reaction type on a prediction question because you have to know that in order to get the products. The whole thing is out of 21. Okay, so give them a mark out of 21 at the top, and then put it on this desk right here. Yes, you did one. So let's have a look at these just to review kind of our prediction flowchart / rules here. Okay, if I'm going to predict the products, the first thing I've got to decide is what? What kind of reaction it is, right? Once I know what kind of reaction is, then I know the pattern that it's supposed to follow, and I can reliably figure out what should be on the other side of the arrow on the product side. Okay? Once I've decided what should be over there, then I need to look at, are there any ionic compounds? If there are, what do I do with them? I swap and drop them, make sure I get the right numbers on them. I also check for special elements, okay, and make sure that I get the right numbers on them if there are any. Then once I've done that, I can go back and balance the entire reaction. If I don't get the reaction to balance, if I can't, no matter what I've done, I can't get the reaction to balance, where have I likely made a mistake? The numbers, right? Probably a swap and drop, or you put the wrong things together and then swapped and dropped correctly. Okay, if you accidentally put the wrong things together, you'll swap and drop them the right way, but you won't get it to balance because they weren't supposed to end up together. Okay, so there's two places if you can't get it to balance, okay, that you may have screwed up. All right, so balancing is the easy part. If it's not working for you, go back and check that maybe you did something else wrong along the way. Okay, but if you can't get it to balance, that's your check that something wasn't right earlier. All right. So our first one here, I've got beryllium reacting with iodine. Two elements. What kind of reaction is it? Okay, what happens in a synthesis reaction? They go together. All right, which one should I write first in that compound? Beryllium. Okay, what I've done in the past here, and I'm going to give away one of my best tricks, okay, is that I'll write this with the nonmetal first and the metal second. Okay, so it'll be like I2 plus BE. I would get at least a third of you on that if I gave that to you on a quiz. Because we automatically go, well, that one was first. It should go first when I put them together. And then you have a non-metal followed by a metal. Is that how we write ionic compounds? Okay, but it'll get a lot of you if I do it. Okay, so don't get caught sleeping, okay, on one like that. Okay, be aware, we have to write a proper ionic compound. Okay, beryllium is a 2+, iodine is a 1-. So this is going to look like that, BeI2, and that's nice because it makes it already balanced. Okay. All right, so did I follow my own rules? Okay, I figured out the type, I swapped and dropped any ionic compounds, I looked for specials, there weren't any, okay, and then I balanced the reaction. Okay, for number 6, I've got potassium, which is an element, a metal, reacting with iron 2 oxide. What kind of reaction starts that way? Single replacement. Okay, how do I figure out who potassium is going to switch with? The other metal, right? Potassium is a metal, so it's going to move the metal out of this compound. That means K is going to end up with O, and iron is going to end up by itself. All right, we said single replacement reactions have the most things to check for. Okay, there's an ionic compound, so I got to swap and drop it. Oxygen's a -2, potassium's a +1, so I've got K2O for that compound. Then I got to look for special elements. Are there any? Right, it's multivalent, but it's not a special element requiring a small number. Okay, all right. Now I got to go back and balance this. I've got 1 oxygen, 1 oxygen, 1 iron, 1 iron, 2 potassium, 2 potassium. Everyone following so far? Okay. Number 7, copper 2 sulfate reacting with magnesium chloride. What kind of reaction is that? It's a double replacement reaction. Okay. In a double replacement reaction, I switch the metals. Okay. So that means that magnesium is going to end up with sulfate, okay, and copper is going to end up with chlorine. They're both ionic compounds, so I got to drop and swap them. This one's a -2, this one's a +2. Is that one okay? Okay. -1, +2. Okay. How do I know copper was a +2? Well, no, it's not it's not. I can't go by the most common. This tells me it was a +2. I go back to the reactant side. This is a -2. This one had to be a +2. The only time I go with the most common charge is if this was a single replacement reaction, copper was by itself. Then there would have been no way for me to know. Okay, then I go with the most common charge. In this case, I could figure it out. Always figure it out if you can. Go with the most common when you can't. Okay, now I got a balance. Good. It's already balanced. Okay, it's 2 chlorines, 1 sulfate, 1 magnesium, 1 copper. Okay, number 8. Butane reacts with oxygen gas. What kind of reaction is that? Combustion reaction. What are always the products? CO2 and water. Okay, do I need to apply the rule of 2 on this one? Yes, 4 is an even number. So start with a 2. That gives me 8 carbons. And it gives me 20 hydrogens, 2 times 10. So 10 times 2 is 20. And now I balance the oxygens. 8 times 2 is 16, plus 10 more is 26. 13 times 2 is 26. Everybody following so far? Okay, number 9. I have rubidium phosphide all by itself. What kind of reaction is that? It's a decomposition reaction. So I'll end up with rubidium and phosphorus. Okay, rubidium is a metal. There aren't any special metals, so it doesn't need any little numbers. What about phosphorus? Yes, it's a 4. It's one of our specials. Okay, now I've got to go back and balance. Okay, I've got 4 phosphorus over here, biggest number, start with that. 1 over here. So what do I need to put in front of this? A 4. That gives me how many rubidium? 12. Okay, that's why it's so important to start with the biggest number. If I'd started with rubidium, I would have got the phosphorus and had to start over. Okay, if you start with the biggest number, it almost always works out the first time. Okay, last one. Lead 4 chloride is reacting with cobalt 2 phosphate. Okay, what kind of reaction is that? Double replacement. Okay, looks really complex. There's brackets, there's all kinds of little numbers, but in the end, it's just a double replacement reaction where I do what with the metals? Switch them. Okay, so that means that cobalt ends up with chlorine, okay, and lead ends up with phosphate. All right, I got to drop and swap. I figured over here that cobalt was a +2. Okay, and the way I did that was that this is a -3. This had to be a +2 in order to make 6 on both sides. Okay, so it's a +2, so +2 and -1 gives me CoCl2. And then for this one, I figured that lead was a 4. Okay, using this. Okay, so it's that's a -1. This has to be a +4. Okay, so I'm going to have +4 and -3. Okay, so I'll have Pb3, PO4, 4. Okay, what should I balance first? Phosphate, present in the biggest number. It's my best bet. Okay, I've got 4 on that side and 2 over here. Okay, how can I make 4? 2. All right, that gives me how many cobalts? Okay, so I'm going to put a 6 there. 6 times 2 is how many? 12. All right, so what do I need to put here? 3. Did that just make my lead work out? Perfect. Okay, start with the biggest number and it's almost always going to pan out by the end. All right, is this making some sense? All right, what I gave to you today is an all prediction worksheet. Don't worry about the balancing at the top. You can come back and do that if you want. There's a couple of balancing questions on that right at the top, and a few of them are way beyond anything I would ask you to do there. If you're starting to feel a little bit cocky, okay, and you need to be humbled, okay, then you can do the tough ones there. Okay, the rest are just prediction. All right, so you can do those. All right, and the key is where it was yesterday on my website there. You can check it as you go. Okay, do each one. If you're having trouble, let me know so I can come around and help you. We'll work on that, guys, for probably about 20 minutes, and then we're going to do the pre-lab stuff for our reactions lab. Okay, so we'll get the Chromebooks out and kind of go over the pre-lab activities for tomorrow's lab. Here. Yes. Okay, so let's have a look at 4 here. So on number 4, we've got magnesium nitride mixed with water. Okay, there's actually 2 correct answers for this one. It just depends on how you wrote water. Okay, so if I've got magnesium and nitrogen together, this one's a -3, this one's a +2, so we'll have Mg3. Oh, that's too small. Okay, sorry, we'll have Mg3N2. Okay, and it's going to react with water, which I'm going to write as HOH. Okay, what kind of reaction is that? Double replacement. I've written water as an ionic compound, and that's why I suggest writing it this way. Okay, so I'm going to swap the metals. Hydrogen is acting as the metal here, right? So I'm going to have hydrogen end up with nitrogen, and I'm going to have magnesium end up with hydroxide. All right, these are both ionic compounds, so I have to drop and swap again. -3 +1, so I'll have H3N. Okay, and then on this side, +2 and -1. So I need brackets around the OH with a 2 outside. Everybody with me so far? Okay, so all I've done is swap the metals, swap and drop my new ionic compounds. When I go to balance this, okay, I've got to look at what's present in the highest number. Well, hydrogen and magnesium. Okay, so I'm looking at magnesium here. I'm thinking I'm going to start with that. If you got 2 that are the same number, like they're tied for the highest number, balance the one with the largest charge first. Okay, so if you got a tie, like we do here, hydrogen and magnesium are both 3s. Go with the one that has the biggest charge. It'll work out better. Okay, so I've got 3 magnesium over here, and I've got 3 over here. The reason I went with that, I knew I was going to end up with more hydroxide here by balancing magnesium first. Okay, so that gives me 6 hydroxides. So now I need a 6 over here. That gives me 6 hydrogens, so I need a 2 here, and that makes my nitrogens work out, and now it's balanced. Okay, does that make sense? Yes? Number 6, yep. Okay, so I've got molybdenum sulfide, so that's Mb, right? M-O. M-O-S, right. Okay, and molybdenum is a, what is it, a +6? Okay, so +6, it's a weird one. Okay, and sulfur's a -2. So when I swap and drop this, I'm going to get 6 and 2, which can be reduced to 1 and 3. Okay. Ooh, that escalated quickly. Okay, always reduce to the lowest common form. Okay, MOS3, okay, reacts with oxygen gas, O2. What kind of reaction is that? It's going to be a single replacement reaction. All right, so that means that oxygen needs to replace the non-metal in this reaction, which is sulfur. So I'm going to end up with molybdenum and oxygen together, and sulfur by itself. Okay, ionic compound, 6 and 2 again, so this is going to be Mu3. Okay, and then I've got S, which is the special element, coming in as an 8. All right, balance sulfur first, largest number. I've got 8 over there and 3 here. Okay, well, what's the lowest common multiple of 8 and 3? Yeah, 24. Yeah, so that's a big number. Let's go over here and go 8 times 3 is 24. Okay, go 3 times 8 is 24. All right, that's balanced. That gives me 8 molybdenums, so I got to go here and put an 8 in front of that. That gives me 24 oxygens. There's 12. That's the lowest terms. I can't divide 3 any lower. Okay, it's just big numbers. Happens sometimes. Haley? 13? Okay. For number 13, I've got barium chloride. Okay, so BaCl, and barium is a, what, a 2+? 2+. It's right here. It's a 2+. Okay? All right, so that's going to mean BaCl2 and reacts with ammonium carbonate, NH4, which is a +1, okay, and carbonate, which is a -2. So I've got a compound made up of entirely polyatomic ions. Doesn't mean I do anything different. I take the 2, I put it here. Okay, I take the 1, I don't write 1s. There's my compound. That's ammonium carbonate. NH4 bracket 2, okay, CO3. What kind of reaction is that? It's a double replacement reaction. What's acting as the metal in this compound? The first one. It's positive. Metals are always positive. This, I think, is your only positively charged polyatomic ion on your chart. Okay, so it acts as a metal. So I'm going to swap that with barium, okay, and I'm going to get NH4 with chlorine, okay, so ammonium chloride, and barium is going to end up with carbonate, okay. -2 plus 2, that one's good. -1 plus 1, that one's good. Okay, they're already swapped and dropped correctly. Now I've got to balance the whole reaction. There's 2 ammoniums over here. Putting a 2 there will take care of everything, right? Because now I've got 2 of these and 2 of these and 2 of them over there. Okay, other one's giving us trouble. Okay.